Hi viewers, we guys are studying in Well-Tech Multitech Dr. Rangarajan and Dr. Saguntala Rangarajan Engineering College in Avadi, and we are from Civil Department doing fine layer. Our project is about partial replacement of fine aggregate by C-sand in GPCC, and GPCC implies geopolymer cement concrete, and this project has been presented by S. Arun, R. Dinesh, D. Langovan and M. Tamilmani. Our project has been guided by our assistant professors Mr. S. Karthik Raja, Department of Civil Engineering at Well-Tech Multitech, Dr. Rangarajan, Dr. Saguntala Rangarajan Engineering College, Avadi. This is our abstract. Actually, we all know in our construction industry, concrete is the main ingredient which is added. In our project, we are going to replace ordinary Portland cement by geopolymer cement and river sand by sea sand. We all know that river sand has been nowadays becoming costly due to its costs and due to transportation, and also natural depletion has been caused, which creates the environmental problems. By using sea sand as a replacement for this project, we can overcome this problem. And the main advantage is that we are going to reduce the emission of CO2 by 80% in our project. Water usage is also reduced here, since we are not going to use any water in mixing, as well as no curing is required for our project. Next slide. Introduction. First of all, what is geopolymer? Geopolymer is a combination of solid aluminosilicate material with a highly alkaline activating solution. Here our solid material is of combination of GGBS and fly ash, and the alkaline solution is geopolymer activator. Our cement has been reported that it has been achieving high early strength and better durability when compared to ordinary cements. The main project I already discussed earlier. We are going to reduce the emission of CO2 up to 80% in our project during the manufacture of cement. Next slide. Once again, previous slide. Here we have put our chemical composition of geopolymer cement in hyperlink. We are now opening the hyperlink. This is our chemical composition of geopolymer cement, in which silica and alumina content is very high. When compared to ordinary cement, there will be lime and silica will be in much quantity, but in our geopolymer cement, silica and alumina is in higher quantity. By reducing the lime content, we can able to reduce the emission of CO2 up to 80%. This is our chemical composition. That's it. Next slide. And these are all the advantages of our cement. As earlier we have discussed, less emission of CO2 during production. It is very superior during fire resistance and acid attack, less shrinkage when compared to OPC. And we are using environment pollutants such as fly ash and GGBS in our project as a components. And I already told that water usage is reduced. Since we are not using any water in mixing as well as curing, and it reduces the construction cost. Next slide. Scope. The main scope of this project is to produce eco-friendly concrete by eliminating cement and river sand. Next scope is we are going to reduce the environment pollution by eliminating the emission of CO2 into the atmosphere. Our objective, if you see about our objective, we are going to find the optimum, that means efficient replacement of fine aggregate percentage as a replacement for river sand in our GPC. GPC means geopolymer concrete. Next slide. This is the literature review. We have taken references from. Next slide. These are the literature review, as I told. These are the 6 literature reviews where we have taken some references. Next slide. This is our methodology of our project. First of all, we are collecting the material and we are doing the base tests for our materials and preparing mixed design and casting concrete cubes. After casting the after finishing curing process, testing of specimen has been done. The major tests are compression strength, flexure strength and split tensile strength. After that, we are comparing, that means economic feasibilities of difference between ordinary conventional concrete and geopolymer concrete has been compared and finalized that which is better, and at last the result has been reported. Next slide. These are the materials we are using in our GPC. First of all, geopolymer cement, next fine aggregate. Both river sand and sea sand has been used. Next coarse aggregate, 20 mm coarse aggregate has been used, and at last geopolymer activator, which is a replacement for water. If we add other than geopolymer activator in our geopolymer cement, solid formation will occur, but it is of no use. That implies when you add geopolymer activator in our cement, then only the hydration process will be started. Next, these are the testers on material. These are the testers we done in cement. We have put the brief procedure and result in the hyperlink. Now we are opening hyperlink for testers on cement. These are the testers we done for cement. First, specific gravity. The specific gravity of our cement is 2.5. And the finest test, finest result is 7.5%, and next consistency test, it is the 30%. 30% of water is required for preparing any cement paste. At last, setting time. Initial setting time of our cement is 10 minutes and the final setting time is 3 hours. That's it. These are all the tests we done for cement. Next, testers on fine aggregate. These are the testers we have done for fine aggregate. First of all, specific gravity of river sand. Specific gravity of river sand has been found to 2.7, and sea sand, specific gravity of sea sand is 2.45. Here we have done chloride content test for both washed and unwashed sand. As a result, we proved that we have reduced up to 75% of chloride content in our river sand after washing sea sand. CO analysis test has been done for our river sand. As a result, we got, this is the CO analysis chart we have done for river sand. And as a conclusion, we got by comparing this our values with the standard IS Indian Standard Code Book 383, we gave the result that this soil comes under zone 2. Similarly, we have done for river sand also. This is the graph for our river sand, the CO analysis chart for sea sand. Here also we proved that it comes under zone 2 by comparing with IS 383. Next, density test has been done our soil. As a result, we got loose bulk density of our river sand is 1.397 and roded bulk density is 1.582 and percentage of voids is 46%. Water absorption. We have done water absorption in both the soils. As a result, we got in river sand there has been 1.5% increase, and in sea sand we got up to 2%. These are all the tests we done for fine aggregate. Next, coarse aggregate. We have done this test for coarse aggregate and we have put the results and brief procedures in hyperlink. Now we are opening the hyperlink. First one, crushing strength. We got 27.03% for crushing strength. Then abrasion. This test has been done to see the abrasion effect of the coarse aggregate. These are the values. These are the result. This is the result we got of value 25.8%. Next one, impact. This is done for check the resistance of our coarse aggregate. The impact value of our coarse aggregate is 18.6%. Next, water absorption. Water absorption of our coarse aggregate is up to 2%. Then we have done CO analysis. for coarse aggregates similarly as we done for fine aggregate. This is the chart of coarse aggregate. As a result, we got 20 mm single sized aggregate has been we are given the result by comparing with Indian Standard 383 code book. As previously we done test for coarse fine aggregate, we also done the bulk density test for coarse aggregate. As a result, we got 1.320 kg per liter and product bulk density at 1.450 kg per liter, and the voids percentage is 50%. These are all the tests we done for coarse aggregate. Next slide. These are the brief properties of our materials used in our project. Next slide. Mixed design. We have designed a mixed procedure of M25 grade concrete by using Indian Standard IS 10262 2000 code book. This is our mixed design. The cement 1 part, fine aggregate 1.75, coarse aggregate 3.40, and water cement ratio is 0.5. We have put the brief mixed design in hyperlink. We are opening the hyperlink. These are the test procedures and test values of our materials. These are the step by step. We are finding the water cement ratio, volume of coarse aggregate, mix calculation. At last, we reported the mix proportion for 1 m³ concrete. This is our mixed design ratio, in which the cement 1 part, fine aggregate 1.75 and coarse aggregate 3.39. In our project, we have used 5 replacement mix ratios. First one 0% C sand, second one 25, third one 50, 75 and 100 respectively. These are the 5 mix ratios we used in our project. Next slide. These are the testers we done on concrete. First one testers on fresh concrete, which have been put in hyperlink. First one slump cone. We all know that how to do the slump cone. The result value is has been shown below for different mix ratios as follows. Next one compaction factor test. The result has been put below for different grades and different mix ratios. Next VB consistometer, and the time has been, and the time is given in seconds. Flow table. Next flow table. The flow ratio has been given for different mix ratios. These are the tests we done in fresh concrete. Next, test is on hot concrete. Opening the hyperlink. First one, compressive strength. We all know that the concrete is very strong in compression. Here we have compared both the compression result by difference between conventional concrete as well as our geopolymer concrete. This is the compression test results for conventional concrete, and this is the result values for our geopolymer concrete, which we have tested for 4 days, 3rd day, 7th day, 14th and 28th. Next, this is our chart for compression test results for geopolymer concrete, and this is split tensile strength. Here also we have compared both conventional and geopolymer concrete as we did for compression strength. And next, flexure strength. Flexure strength. Here also we have done for both conventional and geopolymer concrete, and result has been shown in the chart. Next, acid resistance can be done for our cube, and the test result has been shown that, and at last in the table we have shown the percentage of weight reduction in our concrete cubes. This is our chart value graph. At last, water absorption test is shown. As a result, it shows the percentage of water absorption in our concrete cubes, and the result has been shown in the graph below. That's it. Next slide. Next slide. These are the material prices of our materials used in our concrete. Normal cement, we all know that one bag is of around 360, and reverse and 1850 for per m cube, and coarse aggregate 20 mm jelly 1050 rupees per m cube, and sea sand 300 per m cube. This 300 has been we assumed for transportation cost, and our geopolymer cement, it is of 100 rupees per bag, and the bag quantity is of 40 kg. Next, at last, geopolymer activator, it is of rupees 9.40 per liter. The rate has been shown, values are in Indian rupees. Next. Here we have compared the economic feasibility of for 1 m cube concrete for both conventional concrete and geopolymer concrete. For 1 m cube concrete, the conventional concrete, the total cost is 5564 rupees, and for our geopolymer concrete, it is of 4014 rupees. By using our geopolymer concrete, we are saving up to 1550 rupees for per m cube. Next slide. At last, we have come to conclusion part. Here we have shown the three charts, namely compression, tensile and flexure. Here we have compared the graph value between the compression conventional concrete and our geopolymer concrete, and we compare the increase in strength of these two concretes, and we have shown the graph below. These are the chart flexure strength. Next. Here we have decreased the chlorine content up to 75% in our sea sand by doing tests. And next main important thing in our project is we can able to achieve 90% of our expected strength within 3 days itself, so that we can put the structure earlier into stage. That means, for example, we have designed the concrete for M. For example, we have designed the mix for M25, and at the end of third day, we have achieved the strength of 90%. That means we have achieved the strength of 23 Newton megapascal, so that we can put the structure into earlier usage. And the main problem, water usage is minimized in our project, since we are not using any water in mixing process, as well as in no curing is required for our concrete. Next slide. These are the references where we have referred so much for our project. At last, we would like to thank our guide, Mr. S. Karthikaraja, for helping us to do this project. This is our final project. This is the end. Thank you. Thank you viewers for watching the PPT. If you like our project, please like and subscribe and share with your friends. Thank you.